is a continuation of the section 4.3 notes, and the reference triangles we're referring to are the triangles we used to help draw the unit circle. So you'll definitely want to have your unit circle or that sheet handy that has all the triangles drawn into it. So these are asking you to evaluate the trig functions without using a calculator. We did have non-calculator sections on the test on this portion, so I wouldn't be surprised if we decided to do the same thing again for this one. So you need to be able to draw the triangles and then use the sides from that to evaluate the functions like sine of 3 pi over 4. So for this one, the first thing you need to be able to do is recognize where the angle is located on your unit circle. So 3 pi over 4 is the angle going halfway into the second quadrant, which means we have our 45, 45, 90 triangle set up. So we know that the sides must be square root of 2 over 2 and square root of 2 over 2, and then our hypotenuse is going to be equal to 1. Now the rule for sine of theta is sine equals y over r, so I'm going to be taking the height of the triangle and dividing it by 1. Since dividing by 1 doesn't change the value in any way, then it's just going to be our value of square root of 2 over 2. So square root of 2 over 2 over 1, which is equal to just square root of 2 over 2. The next angle is negative pi over 2. And what's happening when you have a negative angle is instead of measuring counterclockwise around the unit circle, you're actually measuring clockwise the given amount. So we know that pi over 2 is the same as 90 degrees. It's going to make like a right angle. Usually it would go straight up, but since this is a negative one, it's going to go straight down. The other way you could find that value is by taking the given angle and saying since this is not between 0 and 2 pi, you can add 2 pi to it, which in this case is 4 pi over 2 by getting a common denominator. So I'm actually looking to evaluate cosine of 3 pi over 2. So that's the other way that you could find that this one is having you measure to the angle going straight down. Now the ones going straight up, down, left to right, those are the ones we call the quadrantal angles. Those do not actually make triangles per se, but we do know that the coordinate for this is 0, negative 1, because it's going straight down. It doesn't have any left to right motion, it just has the vertical motion. So the rule for cosine is the x value divided by the r value. Well, in this case, our x is 0, and the radius for all of them is 1, because we're dealing with the unit circle, which is a radius of 1. But 0 over 1, it doesn't matter anyways. Your answer is still just going to be equal to 0. And then here's another one where our angle is again outside of the standard 0 to 360 or 0 to 2 pi values. So I'm going to find the coterminal angle again. Instead of adding a number, this time I'm going to subtract because this one's too big. The last one was too small, so I had to add 2 pi. This one's too big, so I'm going to subtract 360 degrees. So we're actually going to be evaluating tangent of 45 degrees. And 45 degrees is the one that's going straight up and to the right. It's halfway through the quadrant. This one again has the sides of square root of 2 over 2 and the radius of 1. And then the rule for tangent is y divided by x. Well, the x and the y values are the same for 45 degrees. So if you're doing square root of 2 over 2 and you're dividing by square root of 2 over 2, then your answer is just going to be 1. The next set of problems you'll encounter on the math lab assignment, very similar concept. It's just that when they say the quadrantal angle, they're telling you that it's going to be one of those up, down, left, or right values on the unit circle. It's only going to be the ones that fall on the x and the y axis. You won't have any of the ones that fall into the diagonal quadrants. So again, this angle is too big. If you subtract 360 degrees from this, then you'll get 540 degrees, which is still too big. So I'm going to subtract 360 again. So we're just finding the coterminal angles that have the same values. And now I'm getting 180 degrees. So it turns out that 900 degrees is the same as 540 degrees is the same as 180 degrees. So for the purposes of evaluating sine, cosine, and tangent, it's a little bit easier to work with the coterminal angle that's between 0 and 360. And 180 degrees specifically is the one that's going straight to the left, because the idea is that we're starting from 0 degrees and we're measuring the counterclockwise rotation. So that ends by turning around completely in the opposite direction. So the rule for sine, our coordinate at this location, is -1, 0 if you're looking at your unit circle. And our radius value is always equal to 1 for dealing with the unit circle. So sine is y divided by r. So in this case, my y value is 0, my r value is 1, so 0 divided by 1 is 0. Cosine is x divided by r. This time my x value is -1, and I'm dividing by 1, so -1 over 1 is -1. And the last one is tangent of theta. So the rule for tangent is y divided by x. So 0 divided by anything is equal to 0. So we've just evaluated the three functions, sine, cosine, and tangent, for a quadrantal angle. Remember, all that it means by being quadrantal, you might want to define that, is that it's one of the ones landing on the x or the y-axis. So it's the 0, 90, 180, or 270 degrees values, the ones that don't make triangles. So now we have one where there doesn't seem to be enough information given, because all they've told us is that cosine is negative. So if we're thinking about our unit circle, we know that quadrant 1, cosine is positive, so it can't be in this quadrant. In this quadrant, we know that cosine is positive, so it can't be in this quadrant. So I'm trying to figure out how to draw my triangle for -2/3, but I don't have enough information yet. The second piece of information they give you, in this case, the fact that cotangent of theta is less than 0 or negative, you need to think about where tangent and cotangent are negative. They're positive in these two quadrants, they're negative in these two quadrants, so we've just ruled out that it can't be in this one. So we're using this bit of information to help us narrow it down to a single quadrant so that I can successfully draw my triangle based on the other trig function they gave me. So now I know to draw my triangle going into the second quadrant in some way. So my triangle is going to have an x value of -2 and a radius of 3, because the rule for cosine is x divided by r. So the radius is always going to be a positive number. If you see a negative, that should be attached to either the x or the y value. So in this case, we're going to have -2 and 3. And then we need to find that missing side. We're going to do that by using the Pythagorean theorem. So I will have -2 squared plus y squared equals 3 squared. The negatives aren't going to affect anything on the unit circle, because since you end up squaring the number, it always comes out to a positive here anyways. So now I have that y squared equals 5, which means y is the square root of 5. And it has to be the positive case, even though usually we take the plus or minus square root when we take the square root of both sides of an equation. We know that it's got to be the positive case over here because our triangle is going up. So it's got to be a positive square root of 5, not a negative square root of 5. So now when I go through and I evaluate the trig functions, sine will be the y value divided by the r value. And we don't need to state what cosine is. In fact, that's what they gave us originally. But they do also ask us for the tangent function. So then tangent is defined as y over x. So I'm going to have square root of 5 divided by -2, but we like to take the negative and pull that out front of the fraction instead. So this would just be negative square root of 5 divided by 2, and we can't reduce that in any way. Okay, for our last example from the movie Zoolander, if you've seen that, the main character is defined as not being an ambiturner. So he can only turn by spinning around to the right. And let's pretend that he's in a situation where he's getting to the end of the walkway and he needs to be facing the 90 degrees direction, which would mean he needs to be facing up from our math unit circle. So usually you would turn to the left 90 degrees. But since he can't turn in that direction, to get him into that same position, that same facing, we're going to figure out how far he needs to turn the other way around, going clockwise instead of counterclockwise. So basically, I'm just asking you for the coterminal angle. If you start from 90 degrees and you subtract 360, that would give you negative 270 degrees. So negative 270 is the same angle measurement. It ends up facing the same direction. Going this way 90 is the same as starting from the beginning and going all the way around 90, 180, 270. So we've just found that to make Derek face the 90-degree position, he's going to turn clockwise 270 degrees instead, which means negative 270 degrees. Positive angles are counterclockwise, negative angles are counterclockwise. So that's all for the notes today. Thank you.